video, we'll be summarizing graphical transformation, specifically linear law. Linear law is important because it simplifies complex mathematical relationships into straight line graphs to make it easier to analyze and interpret. This makes it more convenient and efficient as opposed to curves that can be difficult to analyze. The macro concepts of linear law are systems and models. Systems comprise of different components and take in input to produce a different output. This can be seen in linearizing relationships, where an originally complicated graph can be linearized to a straight line graph. Models are accurate representations of real-life situations and processes. Linear law entails two processes: linearization of relationships and the reverse process, which is basically obtaining the relationship between two variables from a given linear graph.
Let's take a look at a few examples. Look at this quadratic equation y equals ax squared plus b. By plotting y against x, we can see that the graph is a curve, which is not a straight line. The variables x and y are hence not linearly related. However, we can linearize the graph. We take y equals y, x equals x squared. Hence, we can see that m, the gradient, is a, while c, the vertical intercept, is b. By plotting y against x, we can see that the curve is a straight line of gradient a, with vertical intercept b. The variables y and x squared are hence linearly related.
Here, y equals ab to the power of x. By plotting y against x, we can see that the curve is not a straight line and the variables x and y are not linearly related. To linearize this function, we have to manipulate the variables first. To do so, ln both sides. Hence, ln y equals ln ab to the power of x, which is ln a plus ln b to the power of x, which is x ln b plus ln a. Hence, we plot ln y against x with gradient m of ln b and vertical intercept c of ln a. Let's look at the graph of y equals a over x plus b. Look at how complicated it is. The curve is not a straight line and variables x and y are not linearly related. We can linearize the graph by taking y equals y, x equals 1 over x. The gradient will hence be a, while vertical intercept will be b. Now, by plotting y against 1 over x, we get a straight line of gradient a with vertical intercept b. So we can see that the variables y and 1 over x are linearly related.
Let's try applying our knowledge with a practice question. In order to express y equals ax plus b over x in linearized form, we need to convert the equation in the form of y equals mx plus c. To do so, divide throughout by x. Hence, we plot y over x against 1 over x squared. The gradient is hence b and the vertical intercept equals a.
Let's look at an example. A graph of log y against log x gives a straight line with gradient 2 and a vertical intercept 3. Find y in terms of x. We start by writing the linearized form of the equation. Hence, log y equals 2 log x plus 3. Then we manipulate the equation. Hence, the original function is y equals 1000x squared.
How about this? From the diagram, express y in terms of x. We start by finding the gradient m and the vertical intercept c of the linear graph. By using the gradient formula y2 minus y1 over x2 minus x1, we see that the gradient is half. We can use the gradient formula again to find the vertical intercept, which is 1. Hence, the linear graph has the function y over root x equals half x squared. Now it's simply a matter of manipulating the equation to find the equation y equals fx. Y over root x equals half x squared plus 1. Multiply throughout by root x. Y equals half x squared times square root x plus square root x. Hence, y equals half x to the power of 5 over 2 plus root x.
Linear law can be used for many processes. In chemistry, we can linearize equations to find the relationship between the rate of reaction and factors like concentration of reactants, temperature, and pressure of the system. such as in physics, where we can linearize complex equations to give the relationship between two variables. For instance, we can use linear law to find the relationship between resistivity of a wire and factors like length, material, and cross-sectional area as seen here.